Hi, today we're going to look at integrating exponentials. Exponentials have the form e to the x, so we're going to look at things of the form the integral of e to the x dx. We start by looking at the derivative. So if we remember from earlier on in this course, the derivative of e to the x is also e to the x. So this means that the integral of e to the x dx is also e to the x. And then don't forget the plus c. So we're going to look at a couple different examples. The first one is the integral of e to the 3x dx. This is going to involve a substitution. We have a composition e to a function. So u is going to be that function. So in this case, u equals 3 to the x, which means that du is 3 dx. So we have the integral of e to the 3x dx equals, after doing our substitution, 1/3 the integral of e to the u du. So don't forget that du equals 3 dx. We need to divide both sides by 3, so that's where that 1/3 is coming from. And then we integrate, we get 1/3 e to the u plus c. Bringing back in our x, we get 1/3 e to the 3x plus c. Don't forget that you can always double check this by differentiating. In fact, a nice consequence of the fact that the integral of e to the x is itself is that if we have any coefficient a, then the integral of e to the ax dx, so remember a is a number, not another function, just 3, 2, -4, pi, a number. Then all we have to do is take our original function, e to the ax, and divide it by that number a. So if you remember, when we differentiate e to the ax, we would multiply our function by the a. Integration is the opposite, so we divide by the a. So this is a really nice shortcut. So now we're going to look at another example, which is the integral of x e to the x squared dx. And again, we have a composition, e to a function, so we let u be that function. So u is x squared. And that means that du is 2x dx. So that when we rewrite our integral with the u substitution, we get the following. 1/2 the integral of e to the u du. And again, that 1/2 comes from the fact that du was 2x dx. We integrate, we get 1/2 e to the u plus c, and we plug back in what u is. So we get 1/2 e to the x squared plus c. Moving on to our next equation, or next function, we get the integral of dx over e to the 5x. So we're going to rewrite this using rules of exponents, and it's going to become the integral of e to the -5x dx. So remember, when you have something in the denominator and you want to bring it up, you make the exponent negative. And now this is a case of what we talked about earlier, e to the ax. So a is -5. So all I have to do is divide my original function by -5. And that's the same thing as multiplying it by -1/5. So I get -1/5 e to the -5x plus c. And again, don't forget, you can always double check these by actually differentiating what you get and make sure that you end up with what is in your integral. And as another example, we have the integral of cosine of 3 theta times e to the sine 3 theta d theta. Again, we have u substitution, so u equals sine of 3 theta. Du equals 3 cosine 3 theta. And there should be a d theta there. So I forgot to put that there, but that should be there. So when I do the substitution, I'm going to have to divide by the 3 to get rid of that 3. And I get the following. So I have 1/3 the integral of e to the u du. When I integrate it, I get 1/3 e to the u plus c. And then again, I plug back in what u is. So 1/3 e to the sine of 3 theta plus c. And now we've got our last example. So this one looks a little complicated. It's the integral of e to the square root of x plus 1, all divided by the square root of x plus 1. But again, we have e to a function, so we're going to let u be that function. So u is the square root of x plus 1, which I'm going to rewrite as x plus 1 to the 1/2. And then we differentiate. So we bring down the 1/2, we get x plus 1 to the negative 1/2. We'd multiply by the derivative of the inside function, but that's just a 1. So what we have, it doesn't really look like it's going to help us very much until we remember what to the negative 1/2 means. So I'm going to go back and use rules of exponents and bring this back into radical form. So now we have that it's dx divided by 2 times the square root of x plus 1. And this looks a lot like this. The only difference is we have that 1/2. So we want to multiply both sides by 2 to get rid of that. So with our u substitution, we're going to have 2 times the integral of e to the u du. And then we integrate and we get 2e to the u plus c. And then we bring back in what u is. So we have 2e to the square root of 1 plus x plus c. And that's it. Really, it's just a whole lot of u substitutions. And the key is to remember that you can always, always, always double check your answer by differentiating what you get and make sure that your answer is the integrand. Okay, so if you have any questions, send me an email, let me know, and good luck with this.